In this video, we shall be doing logarithm of numbers less than 1, and we will focus on powers and roots. Okay, so we have this first example, 0.4934 raised to power 3. So we'll be using logarithm table to solve this expression. So as usual, we have number and we have our logarithm. And then we write the number on the number side, 4934 raised to power 3. Okay, so the first thing under numbers less than 1, we count the number of zeros before the first non-zero number. So we have just 1 0 before the first non-zero number, we have bar 1. So we call it bar 1 and we handle it as -1. Okay, so we now go to the log tables, look for 49 under 3, difference 4. So we come to the log tables. This is 49 under 3, 6928. So we write that 6928. 49 under 3, difference 4. Difference 4 is 4. So we add up. So this gives 12, 3, 6, 9, 3, 2. So 6, 9, 3, 2. Now, as like it's in indices, when we have powers, all we have to do to the log is to multiply it by that power. So multiplied by 3. So on this my rough work side, I would like to handle that multiplication. But remember, this has a -1, and this negative is just for this whole number part. The decimal part is not negative. So how we handle this is we handle it differently. We multiply the negative part differently. We multiply the positive part, that's the decimal part, differently. So I'm going to have my bar 1 here. So we multiply by 3 and then we multiply by 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 9 is 27. Carry 2. 3 times 6 is 18. 18 plus 2 is 20. So we have 0 and then we put in our decimal points. So that's 2 points this. And then bar 1 times 3 is equal to bar 3. So all we have to do is to add up this. And what we are actually adding is this bar number and the whole number part of the decimal, like the product of the decimal. So that is -3 plus 2 is -1. So all we have here is -1. That is bar 1 point, and then we now write out the decimal part. 0.796. So this is now what we have to go to the anti-log tables to look for to get our number. So we go to the anti-log tables, look for 0.07 under 9, difference 6. On the anti-log table, we have 0.07 under 9 is 1199. 1199. Difference 6. So 0.7 under 9, difference 6 is 2. So we have 9 plus 2 is 11. We take 1 up here, and then we have 10. We carry 1. So 1201. So 1201. Then with this bar, when we come up here, whenever we have a bar number, all that means is the number of zeros before anti-log value. So that is 0.1201. Okay, let's handle another example. So we have the square root of 0.2673. So as usual, we have our number and we have our log. So number is the root of 0.2673. So for the number, we have bar 1 point. So 26 under 7. On the log table, 26 under 7 is 4265. 4265. Difference 3 is 5. So we add up. We have 5 plus 5 is 10. So this is 4270. 4270. And then, as in indices, since this is the root, the square root, so the second root, that means we divide by 2. So as usual, we still handle it differently. So this is bar 1 and this is 0.4270. So we are dividing both sides by 2. Now, the first thing we check for this, whenever it's division, is we have to check the bar value, this bar number. We have to check it and see if the divisor can divide into it without any remainder. Like we know that 1 cannot be divided by 2 without a remainder. So all we ask is, what should we add to 1 to make it divisible by 2? So we have to add 1 to it, right? So when we add 1, we have to add 1 to both sides. And the both sides I mean is to the bar number, if you may. Because in other, like in the actual sense, all we are doing is subtracting 1 from it. So it becomes bar 2 since it's a negative number. But let's just see it like that way, that we have to add 1 to this and then we add 1 to this other side. So we have 1.4270 and then we have bar 2 here, so as to balance it out. So when we divide this part, we have bar 1 as our answer, and then we come here and then handle our division the normal way. 2 can't divide into 1, so we have 0 point. We now join these two. 2 divided into 14 is 7. 2 divided 2 is 1. 2 divided into 7, that is 7 into 2 is 3, remainder 1. Then this becomes 10. 2 into 10 is 5. So we have to join it now. So this is bar 1, 0 point something, so we have to say 0.7135. So that is our value here, bar 1.71335. And that is what we are going to look for in our anti-log tables. So we are going to find 0.71 under 3, difference 5. So 0.71 under 3 is 5164. 5164. Difference 5 is 6. And then we add up. So this becomes 10. 7. 5170. 5170. And since this is bar 1, so since this is bar 1, we have to have 10 before this. So that means the square root of this is 0.5170. Okay, so now let's handle this other example. So as usual, we have our number and we have log. So we have the fifth root of 0.00891. So on this part, the whole number part of the logarithm of this number is bar 3, because we have 3 zeros before the first non-zero numbers. So we have bar 3, and then we now go to the log tables to find 89 under 1. So on the log table, we have 89 under 1, 9499. So that is it here. So we have 89 under 1, 9499. So since we don't have any difference, so that is what we have here, 9499. And since this is the fifth root, we have to divide by 5. So once again, we have to separate this number. So we have bar 3 as the whole number part of our log, and we have 0.9499. And we have to divide both sides by 5. So as usual, we start from the bar value. This cannot be divided by 5 without a remainder. So what should we add in quotes? What should we add to this to make it divided by 5? So that is 2. So that 2, we have to add it here as the whole number part of this. And then we now make this bar 5. So in other words, like in the real sense of it, we took out that 2 because a negative value, when you minus the magnitude, like if we should take away the negative, it looks as if it increases. That is minus 3 minus 2, that's minus 5. And then that's 2, we added it here. So we have balanced out anything. We didn't really change anything. So, but we have to be using that in quotes so that it is easy for our mind to see through. So we have that bar 3. When we add 2 to it, we make it bar 5. So that's 2. We also have it here. So when we now divide, we now have a bar 1. And then on this part, we now have 0 points. 29 divided by 5 is 5, remainder 4. 44 divided by 5 is 9, remainder, no, 8, because that's 40. We have 8, remainder 4. 49 divided by 5 is 9, remainder 4. 49 divided by 5 is 9 again, remainder 4. Then we now add 0 to this. 40 divided by 5 is 8. So, but it's 4 figure tables we deal with. So our values here has to be 4. We approximate. When we approximate, we are going to get, that's this comes here. So this making it 10. 1 goes over here, making it 10 again. So we have 5900. So since there is no 0 is our whole number part of this, no need to add up anything. So all we have is bar 1.5900 approximately, because we don't handle 5 values. On our anti-log tables, we see 4 numbers. So on the anti-log table, what we have to look is for 0.59. So since under 0 remainder 0, so just 0.59 under 0. We come to the anti-log table and then we look for 0.59. 0.59 under 0 is 3890. So we have a 3890. So since it's bar 1, we have just 0.3890. So you could see it's easy, but I know we thought something that is a little bit like not the usual math we do. So now what we are going to do is to practice with these bar numbers, practice the multiplication, division, just using simple examples to practice it. So the first one we'll have is bar 1.9 multiplied by 3 for our practice. So we have to multiply separately. So we have bar 1 and we have 0.9. So for multiplication, we start with, okay, we can start with anywhere for multiplication. We can start with anywhere. Though to make it quicker, we start with this. So 0.9 times 3 is 2.7. That is times 3. And then bar 1 times 3 is bar 3. Then we now add up the whole number plus the bar value. So we have minus 3 plus 2. Minus 3 plus 2 is 1. That is minus 1. So we have that as our answer. This is equal to bar 1 point, the decimal part, 7. If these were those 4 values, you just add up those 4, you rewrite those 4 values here. All we just have to deal with is if there is a whole number part of multiplying the decimal part of our log number, all we have to do is to add up that whole number to the product of the bar value. Okay, so let's have another example. Let's say we have bar 4.3 times 2. So what we have to do is, for multiplication, we can actually do that without writing them separately. So 0.3 times 2 is 0.6. So for this one, we don't have any whole number parts to add up to here. So all we have to do is 2 times bar 4 is bar 8. Okay. So let me redo this one, doing it on the same line. 3 times 0.9 is 2.7. So we write our 0.7, then carry 2. 3 times bar 1 is bar 3. So minus 3 plus 2 is minus 1. So as easy as that, right? Okay. So let's do more examples, actually on division, so that we can grasp how to work with that division. So we have bar 6.8 divided by 2. So for division, it's better we write them separately, bar 6 divided by 2 and 0.8 divided by 2. So on division, we have to check the bar value first. So on the bar value, 2 can divide into 6 without any remember. So this is not a challenge. So this is bar 3 as our value here. And then when we divide through for this part, we have 0.4 remaining. So this is not a challenge. It's not every time we have to handle that challenge. So next we have to do something like bar 2.5 divided by 5 divided by 5. Okay, so we write it out separately. We have bar 2 divided by 5 and 0.5 divided by 5. So remember, we have to start here. We have to look into this. We can't divide this without having a remainder. So what do we add in quotes to bar 2 to make it divisible by 5? So we add 3 to it. So that 3 we also add it here, right? So making this bar 5, right? So that by the time we divide into bar 5, all we have left is bar 1 point. And then this is now 3.5. So you already know it's 0 point. So we can now join this. 35 divided by 5 is 7. That is 0.7. So this is it for this one. You could see, I hope you're getting it easier now, right? So let's do more. We have bar 3.8 divided by 4. Bar 3.8 divided by 4. So we have our bar 3 divided by 4 and 0.8 divided by 4. So looking here, we see it couldn't go through without a remainder. So what do we add to this to make it divisible by 4? We have to add 1. So that one we have to add it here, and then this becomes bar 4. So we have bar 4 divided by 4 is bar 1. So this is 1.8. So this gives us 0.18 divided by 4 is 4 remainder 2. So that we add up 0 to it. So 20 divided by 4 is 5. So meaning that we have bar 1.45. So with practice, we get better.